Hello, Leetcode here. Today we'll be doing Leetcode number 1249, minimum remove to make valid parentheses. This is also Facebook's #1 most asked questions in the past 6 months, and the problem itself is pretty straightforward. So you're given a string that is a mixture of parentheses and lowercase English letters, and we are to remove the minimum number of parentheses so that our resulting string has valid parentheses. So take for example, example number 1, we have Leetcode with a bunch of parentheses in it. So we can see that there is an extra closing parentheses that would make this string invalid. So and the problem states that we only need to return 1. We can return any valid string. So as we can see, the output here could be this, but these 2 strings would also be accepted. And we can take a look at the second example. So we have A, B, C, D, also with just parentheses scattered around. And we can see that here this is an invalid parentheses, and we would have to remove this because there is no opening parentheses to match it, and this would cause this string to be invalid, and this is the one we have to remove. And the third example, we just have a bunch of parentheses, and all of these are invalid. These are like closing parentheses with no opening parentheses to match it, and these are just opening parentheses that have no closing parentheses to end it. So for the sake of being able to show edge cases better, I have went ahead and just modified that first example input. And one approach we could take here is we could kind of do a 2-pass approach where we remove all the invalid closing parentheses first, and then do a second pass where we remove all the invalid opening parentheses. And what we could also do is just split the string every time we encounter an invalid parentheses. However, in Python, string splitting takes O of n time, and because we're already traversing through the whole string once, doing that splitting every single time we encounter invalid parentheses would lead us to a time complexity of n to n squared. So instead, what we will do is we will kind of do also a 2-pass approach, but this time we will only mark where our invalid parentheses are, and we will, after we do that, we will iterate through the string again and construct our new returning string, ignoring all the indices that we've marked as invalid. So just to walk through the program, will also have a stack that will track our closing parentheses and our opening parentheses, and we know that a closing parentheses is invalid if there are no opening parentheses that will match it. So when does that happen? That happens when there are no opening parentheses in our stack. So as we can see, the first one, there are no opening parentheses in our stack yet, but there is a closing parentheses. So we will keep track of that index, and that is index 0, and then we can just go ahead and ignore the alphabet characters since there is no statement saying how we should handle it. And whenever we encounter opening parentheses, we just want to mark those index and add it to our stack for now, and we will pop them off once we encounter closing parentheses. So for now, we have index 4 and then 6, and now we have encountered our first closing parentheses, and we can see that this stack of opening parentheses is not empty, so we will not be adding this to the closing parentheses stack. Instead, what we will be doing here is we will pop off from that opening parentheses stack, and same for this one. We will also end up popping this off, and here we encounter in closing parentheses, but now our opening parentheses stack is empty, so we will add this index to our array, and here we have an opening parentheses, and we will just add that, and because we've reached the end, there's no further characters to be processed. This never gets popped off, and therefore gets added to the result of the indexes to ignore. So just to build our string based off the indexes to ignore, so we are ignoring index 0, 1, 2, 3 are in, and 4 is in, and same for the rest, and we will be doing this until we hit 13, and we will ignore 13 and ignore 14. So this is our resulting string, and the time complexity of this, we are traversing through the entire string twice, and that gives us 2n, which gives us a big O of n time complexity. And because we're using this data structure of a stack to store the indexes to remove, it will be at most also the size of the string, so O of n space complexity. Alright, so onto the coding solution. As I mentioned earlier, we will be using a stack to keep track of the indexes where we need to remove the parentheses, and the indexes where we will ignore in our second pass to build the string. And just for simplicity, I will go ahead and name my opening parentheses left parentheses, and I will denote my closing parentheses as right parentheses. So our first iteration, we will just be marking all the invalid parentheses, and we do need to know the index, and our three conditions were if we have no opening parentheses but we encounter closing parentheses, then we know that this is invalid parentheses, and that we will be ignoring this in the final string. So that, and we will be appending this index to the stack of right parentheses. And then our second condition, so if we encounter an open parentheses, we will just append it to the stack, and once we encounter closing one, we will remove it from the stack. And here we are just popping from our opening parentheses whenever we encounter closing one, and we know that it has that matching opening parentheses because we have passed this statement, and we are also just checking that they are parentheses characters, since this input string can also have other alphabetical characters. So just for faster lookups to check if our index is one that we need to remove, I will combine these two stacks into a set. And here is also our resulting string initialized. And just iterating through that original string again, so we know to include the character in our final resulting string if that index wasn't marked. So if I is not in the indices set, then we will add this character to the resulting string. And we will just go ahead and return the result, and this should run. As you can see, this ran not at the greatest time, but the memory was very efficient. But yeah, that was minimum parentheses to make string valid. If you like this video, please like and subscribe to this channel, and if you have any questions, please leave them in the comment section. Bye!